All right, here we go. So once again, worksheet 2.3, numero 8, which is the motorcycle problem. So it says a motorcyclist who is moving along an x-axis directed towards the east has an acceleration given by this mess. So acceleration at time t is 6.1 minus 1.2 t. As long as your time is between 0 and 6 seconds. Cool. So apparently what happens after 6 seconds we just don't care about. Does that make sense? That's kind of what that's telling you. Cool. Like maybe after 6 seconds he stops accelerating and the velocity becomes constant or something. Okay, so let's see. A says... Oh, I'm sorry. It also tells us at t equals 0, the velocity and position of the cyclist are blah, 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 blah. So the velocity at time 0 is 2.7 meters a second, and the position of the motorcyclist at time 0 is 7.3 meters. So that's our given information. Everybody good up to there? Move that out of the way. Thank you. Okay, so let's see, what do we got? So part A, what is the maximum speed achieved by the cyclist? Thank you so much. What is the maximum speed achieved by the cyclist? So thoughts about what we need to find here, you guys? Sure.
When we find like the equation for velocity and then find where it like intercepts the x-intercept, it goes through the x-intercept and then divided by 2 and plug that back in for y.
I gotcha. So that does happen to work here because I think the velocity equation is a parabola, right? But if it wasn't, that wouldn't necessarily work. Do you know what I mean?
Yeah.
So let's see if we can kind of come up with a general way of doing it. All right. So I guess let's start with this. Your first intuition was right. We need to know something about velocity, right? Wasn't that what you had said? Figure out where it hit 0 and then divide it by 2, and, right? So let's start there. How do we find that velocity equation, you guys? We know our acceleration. How do we find the velocity? Take the integral, right? And this time, we don't want the change in velocity. We want the actual velocity, right? So we're going to do an indefinite integral this time. Okay? So the velocity at time t is the integral of acceleration, which is the integral of this mess, 6.1 minus 1.2 t dt. So what's the integral of 6.1? 6.1 t, right? Minus, what is that, 0.6 t squared, right? Yep.
How did you know this from other things?
So I'll give you 2 answers. Reason number 1, the question is asking us to come up with an exact velocity at an exact time, right? It wants to know, at some time it hits a maximum velocity. What is that maximum velocity? So I need to know the actual equation for what the velocity is at different times. It's the only way I can find it. Secondly, here's a good hint. Anytime I give you conditional points, that's a pretty good sign that you're going to use an indefinite integral. Okay, and you'll see why in just a second. All right, have I lost anybody? Are we okay? Okay, so we've got this. Now, because I did do an indefinite integral, what's the one other thing I got to tack on here? The plus c, right? Follow? So, but that doesn't help me if I don't know what c is. Oh, this condition here tells me that if the velocity is 0, or sorry, if the time is 0, the velocity is 2.7, right? So I can plug 0 in and solve for c. So if time is 0, so I get 2.7, right? Here, let me do it this way. Oh no, 6.1. So this guy here is going to give me this equation. 2.7 equals 6.1 times 0 minus 0.6 times 0 squared plus c. Does that make sense? All the zeros go away. Oh, c is 2.7, right? Okay, well that means velocity times t is 6.1 t minus 0.6 t squared plus 2.7. Cool? Is that bothering anybody the way that's written? It's killing me. I'm going to do this just because I'm a weird math guy. I'm going to put it so that the powers are in decreasing order.
Oh, yeah.
Is that just me that cares about that?
I agree.
Ah, that looks much better. It's making me really anxious. All right. Cool? All right. So now that we know that, the question wants to know what's the maximum velocity, right? So how do we find maximum? You set the derivative equal to 0, right? So this is a little bit silly the way this problem is set up. When I take the derivative of that, what am I going to get? Oh, the acceleration again, right? Does that make sense? So, Vmax occurs when the acceleration is 0. So 6.1 minus 1.2 t equals 0. So algebraify it, and your t turns out to be 5.03. Thank you. I guess I could have dug out my answer key. So 5.03 seconds. Follow? Kat, are you okay? You're making a squidgy, what the hell did you just do kind of face?
Yeah, you lost me.
Okay. So can we forget physics for 1 second? You're like, please. So check it out. So, oh man, who left all this garbage all over the board? All right, so check it out. Suppose I give you this. F of x equals, I'm just going to make up some nonsense equation, okay? I don't know, maybe 3x squared plus 2x minus 7. Okay, so that's a parabola, right? Good. Suppose I wanted to find the maximum point, right? So you keep going to find the x-intercept, divide it in half, right? And that works as long as it's a parabola. If it's not a parabola, that doesn't work. So the idea is, well, what's this parabola going to look like? It actually opens. It opens up. Okay, well, whatever. Okay, so the parabola is going to look, I don't know exactly what it looks like, but it's a parabola that opens up, right? Okay, so check it out. My slope is negative. It gets less negative, less negative, less negative, less negative, less negative. What's the slope at the very bottom? 0. Do you see that? Okay, so mathematically, what's the connection between the slope at a point and this equation?
I know what you're like saying. Where like if it's when it's 0, it's like even there the max. Like for this case, it'd be the min on the.
Right.
Yeah.
But so I guess what I'm saying is, so this is the equation of the function, and we want to know where the slope is 0. I don't want to know where the function is 0. I want to know where the slope of the function is 0.
Okay.
So how do I use this equation to find out information about the slope at different points? Okay. So this. Go ahead.
Well, I know they take like the derivative and then set that equals to 0, but I don't know why that comes in like physics. Because like when that counts, like I don't know how that factors.
I gotcha. Okay, so there's two things here. So thing one, first of all, are you okay with the fact that the derivative of a function gives you the slope at a point?
Yeah.
Big concept. Good?
Yes.
So the derivative of a function gives you the slope at a point. Good? So what I would do is I would take the derivative of this function, set it equal to 0, and that would give me the x value at which you hit this minimum. Good? So that's thing one. Now, thing two, what does it all have to do with physics? Well, in physics, if you start with position, what's the slope of a position time graph? Do you remember from last year?
It's the velocity.
Good. And so if the slope is velocity, that means the derivative is velocity. So if I take the derivative of position time, that gives me velocity. Good?
Yes.
Similarly, if I take one more derivative, do you remember what the slope of a velocity time graph is? That's acceleration. Cool. So in math, to find a max or a min, you take the derivative and set it equal to 0. Cool. So what we just did was we were trying to find the maximum velocity, right? So I took the derivative and set it equal to 0. But it happens in physics, those derivatives have meaning, right? It's not just the derivative of velocity. That derivative is acceleration.
So the acceleration at that point is to max velocity.
So the time at which the derivative equals 0, the time at which the acceleration is 0, corresponds to that maximum velocity.
But it's the equation for acceleration. Like the slope would be the equation for acceleration. So once you find the x, when you set the equation for acceleration equal to 0 and you find the x, what does that mean in terms of acceleration? Isn't that the acceleration at the x point?
Yes. So you have to go one step after that. So what I just did. So I think we're in agreement. We understand that we need to find the time at which the acceleration is 0, right? You good with that? So that was the last thing I did. Somewhere back here. So I found the time at which, so the maximum velocity occurs when the acceleration is 0. And that's here, that's at this time. Good? So you're right, if I plug that back into the acceleration, I'm just going to get 0. What I want to know is the velocity at that time.
Oh, so put it back into the velocity.
There you go.
Oh, okay. Okay, that's
good.
Okay, yeah.
Okay. Excellent. All right, so yeah, so now, exactly like we were just saying, so now we take this time and plug it back into the velocity equation. So the velocity after 5.03 seconds is this mess, 6.1 times 5.03 minus 0.6 times 5.03 squared plus 2.7, and whatever that gives you is the answer. All right, so is everybody okay with part A? Okay. Part B. So, part B, what total distance does the cyclist travel between 0 and 6 seconds? So this is very similar to what we just did in 10C, right? I am hesitating a little bit. All right, so to find the total distance, I need to trying to figure out how much detail I want to go into here. I'm going to cheat real quick and see a thing. Let me see if we need to worry about a thing, because if we do, this problem is harder than anything you'd see on the AP test, and I can probably not worry about it. O-M-N-O-P. I'm trying to figure out if it turns around at all during that time interval, because if it does, it makes the problem more complicated. Okay, yeah, all right. So it doesn't matter. Okay, so everybody okay with what we've done so far?
Yes.
All right, so the last thing we got to do is, it says, how far does the object move between 0 and 6 seconds? So how do I find displacement between 0 and 6 seconds, you guys? So that'll give you the change in time. That's okay. Oh, you're warm. The definite integral of V, yeah. So to do part B, to find our displacement, we're going to take the definite integral from 0 to 6 seconds of the velocity function, which was this mess here. Oh, well, actually, I guess this mess after I rearranged it so that it was in the right order. So negative 0.6 t squared plus 6.1 t plus 2.7 dt. So take your integral and do it. Cool? All right, so really quickly, I don't want to spend a ton of time on this, but for those of you that are like, I want to understand every little subtlety of this problem, technically this gives me the displacement between those two times. Okay, so if it had been true that the object had turned around during there, that wouldn't actually give me the distance we'd traveled. You know what I mean? Right, like if it had gone forwards and then come back a little bit during those 6 seconds, then the distance is bigger than the displacement. So what you'd have to do is you'd have to find out the point at which it turned around, find the displacement forward, find the displacement backwards. It would be a little bit more complicated. And I wouldn't do that to you on a test. I was hoping I didn't remember. And I didn't. So yay me. Good? All right. Yes.
How would you know if it did
Turn around?
Yeah.
Couple ways. One way you could do it is figure out if the velocity is 0 at all in there, right? The only way that it would turn around is if the velocity is 0. And I guess you could, use the quadratic formula and see at what times your velocity is 0. Do you know what I mean?
Yeah.
So that's probably the easiest way to do it. The other way you could do it is you were given a condition for the position. So you could use that condition to find C and graph your position and see if, if there's any maxes or mins in that.
And on the AP test, will we have to check for that, or can we just
I don't think so. Yeah,
assume that it won't?
yeah, I think you can.
Okay.
Yeah. So I don't remember, we had back to school night last night, and I told one of the, I don't know if I told 4th or 5th hour parents, but when I sort of developed this class, my first year, I didn't know, I found out I was teaching AP physics like a week before the school year started, and it was like, shit. So I literally just based the class off of Calc 1 at U of M. And then after I'd been teaching for a little bit and got ahead a little ways, then I went and looked at the AP website to make sure that I was getting all the stuff. And so some of, like this problem is probably a little bit harder calculus than anything you'd see on the test. And it's the sort of thing you would see in a first year course. I still think it's valuable, So, does that make sense?
Yeah.
Okay, cool. All right. I feel like eyeballs are melting. I feel like we should stop, yes? Okay. So, to be clear, video 2.4 is due Monday, and then worksheet 2.4 is due Tuesday. We are looking at that test on Wednesday, so if you want to get a jump start on it, maybe take a look at those practice tests. They're optional and beneficial. Cool? No, the ones that I put on Schoology from the last 2 school years.
Oh, okay.
Does that make sense?
Yeah.
Cool. Huh. Cool. Kat, are you good with that now, or? So the big trick is find the maximum or minimum of the function. You take the derivative and set it to 0, right? But then to find out what the maximum is, whatever you get when you solve for 0, you gotta plug it back into the function. I think that's what's easy to miss.
Oh my God, they're pictures.
I'm going to make this random guess here. So here's the equation for velocity of something at some time. Okay, and maybe the function looks like that. Okay? So, yeah, I wasn't trying to make some crazy polygon. Okay, so this has some equation, right? I'm going to make up some nonsense. Maybe.
Oh, like quadratic.
Maybe this is b of t 16 plus, right?
But
Good.
no, apps,
All right. So suppose I want to find out that max. Okay. Think about what's happening.
The next, that's
So
wild.
here to here, my velocity is increasing, right?
What, sure?
Here, the velocity is maximum. And over here, the velocity is increasing, right? So in this range, you agree that my acceleration is positive, and in this range, my acceleration is negative, right? Right here, what is the acceleration? Zero, right? Acceleration is not zero. Similarly, zero here and it's zero here. Here? No, the velocity is not zero. The velocity there is, whatever this number is. So what I'm going to do is I'm going to take the derivative and find out what the acceleration is. My acceleration function is going to be, whatever, 30 t to the 4th plus, right? Good. So now, when I set that equal to 0, it's going to have a bunch of different solutions. Those solutions are going to tell me the times at which my acceleration is 0.
So like a lot of just
Yeah. But that's not what the question wants to know. The question wants to know what's the velocity at those points.
I think the questions are both of us. They're all just
Acceleration is the velocity. The only way the velocity will be 0 is when it crosses that axis.
the exercise.
Right. Do you see what I mean? I probably shouldn't be crazy. So let's do this. Let's start with a real live example, all right? And let's do one that's not a quadratic.
Let's take a
Real
tutorial.
graph.
Little
Are you
did I
really
know
going to use the graphic calculator?
I don't know why I didn't know that.
So let's do this. Suppose I give you velocity
So
times
stupid. They didn't tell us at all.
Advertise what?
We're in the class meeting, like Victoria told me you were like walking the third hour, and she's like, "Oh, class meeting." And I was like, "What?" I literally had no idea. Those are not great.
So let's graph that with see what it looks like.
Yeah, I don't even know.
All right? Yeah, that's fine.
Whatever.
I think you know how to do that.
I feel like I need to be
What the? Who's?
Probably making stuff up on the spot.
Diploma application.
Oh, I saw that.
What does that even mean? I really
Like,
need to find ways to use it.
A million essays. My mother yells at me every time.
Does it fit? Oh, really?
Whenever I'm like inside, yeah, I need to like
Yeah.
I kind of like finish. I kind of was like ready to just like everything.
Yeah, but it's just really cherry. And I like don't want to I don't want to do
Graphing calculators in the air, not friends. Here. We're doing on time. Oh no, only 5 minutes. Desmos, where is it? Right here. Desmos. Alright, so what does that say? 4t cubed? Is that what that says? So 4t cubed.
Minus x, or minus 6x squared, plus
there we
3x
Plus 3, oops. Plus 3x
minus 5.
minus 5. Okay. Yeah, it's right. It's Desmos.com. It's super badass. Okay, so I don't like that function. Darn it. Here, let me do this. Let's do that. Cool. So I just got rid of the minus 3. Okay. So I'll write on this so you can kind of see what's going on. Okay. So here we go. So we've got velocity at time t is 4x cubed minus 6x squared minus 5. And that's what the function looks like, right? Okay. So suppose I wanted to figure out this velocity right here, arbitrarily. Or this, well, you pick. Do you want to do this one or this one?
The top.
The top one? Okay.
This is a velocity time graph.
This is a velocity time graph. Yeah, so this is this.
Okay.
Good?
Yes.
All right, so I want to find the time at which it hits this maximum velocity. Okay, understanding that it's going to decrease and then go up again, but you know that, like locally, that's a maximum velocity.
Because I'm still thinking about like, I think I'm thinking too much about like physically if you like toss a ball in the air when it's the max, like the velocity is 0. But that's not how velocity time graphs work.
Right.
I think that's just because like I like understand everything you're saying, but I think that's just like getting in my head.
Gotcha.
So yeah, I think we're good. Like I think it's fine. I think we're good.
You sure?
Yeah.
So I mean, so really quick, you're gonna take your derivative, right? You understand the velocity acceleration's positive here, right?
Yeah.
0 and then negative, right?
Okay, yeah.
So you're gonna go, oh well, that's 12x squared minus 12x. Oh, that's nice. So that's the same as 12x times x minus 1, right? Did I do that right? Well, that's 12x. Yeah. Right?
And then you find
So set it equal to 0. So it happens once at 0 and once at 1. Once at 0, once at 1, right? So that was a lucky example, right? So now if I want to find the velocity at those points, now I got to plug 0 back into here, or plug 1 back into here, and that'll give me these two values, right? Like if I plug 0 in, oh look, I'm going to get -5, halfway between 4 and 6.
Makes sense. Yeah, that absolutely does make sense. I just need to get it in my head that what is a velocity graph if it's not something, it's something.
Right.
Yeah. Okay.
Good?
Thank you for going over that.
Yeah, absolutely. What's up? One of us made a mistake. Let me grab a copy of my sheet over here. Number 4, the zebra problem. The graph to the right gives that. Did you, so this is a thing I need to talk about. The book sets these up, I keep meaning to fix them. So where it says AS is 12, did you understand that that means this is 12? Right, AS is that top mark, so that's 12.
No. Okay. Yeah. I should have.
So each little box is 2.
Yeah.
Cool?
I did it
As though the intercept was 12.
Oh. We were at this hotel, and they had like all these. Oh, it's only 40%. So you really get the short. You should take the hands and
What if someone decides?
What did I get?
what's that?
I don't either. Have a good weekend! Bye. Later on the weekend. If I find these or not, I will be angry. So make sure you do it. I know, right? Balloons and playdates and the charging station. It uncharged it? Oh, he was the one that told me to buy this. Yes. And actually, hang out for 1 minute if you would. Totally forgot that I was thinking this wasn't going to affect you guys, but it does. Oh wait, oh, but this is not a bad thing because I lose my first and second hour on Monday, not my 6th hour. Oh, right on. Excellent. Yes. Hang out for 1 minute. They'll release you guys by PA. I promise you won't be late. Good? I will probably not worry about checking in because so many people are going to be gone, you know. So, thanks. One iPhone cord? Oh no, 2. Cord 2.
Tracker?
Yup.
Do you want to see my homework before I leave?
Hang out for 1 minute. But no, I'm not worried about checking homework.
Okay.
I mean, I am, but there are other things that are more pressing.
Are you doing?
Good of itself. Good. Oh yeah. True indeed. Yeah, hang out for 1 minute, and then yeah, I'll let you guys go. Oh, look at all the garbage bags.
Nice. Better.
Utility knives.
No, period.
These. Hello. I got mailboxes. Really bad at returning papers. You guys are gonna get mailboxes. I'm excited. Hooray!
I left him with my e-mail book on accident.
I was thinking you were
I just don't know if you left it there. I just used it for 40 minutes. I'm gonna do it in the first hour. Okay. Well, what did you get?
All right. Hey guys, a couple quick things before I release my seniors who need to go. So here's the deal. For some reason I got mixed up on these times and I was thinking everybody was going to be here. So here's what I'm going to do. I want to go over a little bit from the homework. What I'm going to do is everything that I do in class today, I will record and make a video of and post it on Schoology. I'll send out a link, so if you guys would like to go back and watch it before you start worksheet 1.3b, you may. And
excuse the interruption, this announcement is for all seniors with the last letter of their with the first letter of their last name, beginning G through O. Please get a your 6 hour. Okay, seniors, G through O. Thank you.
okay, so I will record what we do in class today. And so I realized 4 minutes ago that, so my first and second hour I didn't lose anybody, but I'm losing some of you today. But Monday, I'm losing my first and second hour because there's an evacuation drill, and I'll have you guys. So my point is, we'll have some extra time to spend on this on Monday. So even if you don't get a chance to watch that video, I can still answer individual questions, etc. Cool? Does that make sense? So check your Schoology if you want to watch that video. Worksheet 1.3b is due on Monday. Good? Okay, seniors, off you go. Have a good weekend. Oh, what happened to my clown? Oh, I'm still recording. Hi. Okay.